Good morning, students. So today I will be giving you a lecture on characteristics of database management system and the three types of database models used for defining the structure of a database. So let's start with the characteristics of database management system. The first one is data representation. Data representation is divided into two parts: high-level details and low-level details. The high-level details of data represents information related to the table and the number of records in the table and the attributes or the fields that form the records in the table. On the other hand, the low-level details deals with the physical storage of data. That means how the data gets actually stored on a storage device. The next characteristic of DBMS is performance. The performance of a DBMS is assessed by its response time. In any database, the data stored should be in such a manner that it can be accessed quickly and conveniently. So speedy access and retrieval of data from a database indicates a faster response time. The next characteristics of DBMS is integrity. When large number of users concurrently use a database, the data items and the associations between them must not be destroyed. So any storage, insertion, deletion and updation of data have to be performed in such a fashion that the system can recover from a hardware failure if any error occurs. A particular table or a database can maintain its integrity by fulfilling the property of atomicity, consistency, isolation, and durability. In short, we refer to that as the acid properties. Atomicity ensures that any activity, if performed on a database, should be completed in its entirety. Say for example, if insertion of data is an activity that is being performed by user 1 on this database, then it should be completed in its entirety. But in the midst of its execution, if any error creeps up or if any error occurs, the whole process of activity, that is insertion, should stop immediately and it should revert back to the state where it was free from errors. Consistency ensures that there should not be any discrepancy in the data stored in the database when any activity is performed on a database by a user. Isolation ensures that if any activity is performed on a database, then no other activity should interfere in that process. This means that if insertion is the activity that is to be performed on a database by a particular user called user 1, then the rest of the users performing the operations such as deletion, updation and storage on this database should not interfere in the activities performed by the user 1. This means that every activity to be performed on a database should run in isolation. Durability ensures that the data stored in the database should persist even if the system malfunctions. In this way, the ACID properties maintain the integrity of the data stored in a database. The next characteristic of DBMS is minimal redundancy. I have already explained you in my earlier presentation that redundancy means duplication of data. And when there is duplication of data, it leads to problems related to insertion, updation, and deletion of data. This creates inconsistencies in the database. Moreover, redundant data consumes a lot of disk space. Redundant data consumes a lot of disk space. That means when data is redundant, there is duplication. And when there is duplication, there is more data in the database, which in a way consumes a lot of disk space. So redundant data should be eliminated from a database by a process known as normalization. This process of normalization simplifies the database and eliminates the redundant data. The topic of normalization you will study in detail when we reach class 12. As of now, just try to understand that minimal redundancy is also a characteristic of the database management system. Consider the table called classroom as shown in this slide. This table has redundant data. This is because the student bearing the name Ram with the roll number 100 occurs twice in the table, and this creates redundant data which consumes lot of disk space. If such type of redundant data exists in a table or a database, it will create inconsistencies in the database, and also it will consume more disk space. So even though there are 3 different students bearing the same name Ram in the same class, they cannot be identified with the same roll number, because if the roll number is same, it can identify only one student bearing the name Ram. The other 2 students bearing the same name Ram cannot be identified. So what you can do is that put unique roll numbers for the 3 students bearing the same name Ram, so that you can easily distinguish between all the 3 students who have the same name Ram. This is done by putting the roll number 100 for the first student bearing the name Ram, roll number 101 for the second student bearing the name Ram, and roll number 102 for the third student bearing the name Ram. As a result, the redundant elements has been eliminated from this table called classroom. As a result, it helps the table to give proper information about all the students in a classroom. Now the table is also free from inconsistencies. The next characteristic of DBMS is privacy. Privacy of DBMS implies that individuals and corporations as a whole should have a due right to determine by themselves when, how, and to what extent information available with them is to be transmitted or shared with others. The privacy of DBMS also implies that individuals and corporations should circulate information only within the four walls of their organization. Such information should not be exposed to a different party, which is in no way connected with the organization. For such reasons, certain data should be given restricted access to maintain its privacy, so that it is accessible only within the employees of an organization. The next characteristic is security. Security of data means protecting data against accidental or intentional disclosure to unauthorized persons. It also implies security from unauthorized modification or destruction of data. Nowadays, DBMS packages are having inbuilt mechanisms to authenticate users and allow them to access data as per their authorization. Now let's discuss about the three different types of database models. First of all, what is a database model? A database model is any model which describes the structure of a database. The first database model is the record-based model. The second one is the object-based database model, and the third one is the physical data model. The record-based database model consists of three parts. The first one is the hierarchical model, the second one is the network model, and the third one is the relational model. In the present scenario, the use of relational model is dominant over the other two. In a hierarchical model, the data is represented in the form of records, and these records are organized as a collection of trees. If you see the figure in the slide, the figure is in the shape of an inverted tree. The hierarchical model follows one-to-many relationship, where there can be at most one parent entity but can have many child entities. In the given figure, engineers and technicians are the child entities of the parent entity workshop. From the figure in this slide, we can clearly say that a workshop is being conducted by an engineer. We can also say that the workshop being conducted by the engineer is being attended by many technicians. So there is a one-to-many relationship between the entity workshop and the entity technician, as for one workshop there are many technicians who will be attending that workshop. We can even find out who are the technicians attending the workshop, and also the number of technicians attending the workshop, as I have already explained. But in case many different workshops are being conducted by the engineer, this model, that is the hierarchical model, won't be able to tell you the names of all the workshops being conducted by the engineer. This is because this hierarchical model follows only one-to-many relationship, where there can be only one workshop. There can be many engineers, but there has to be only one workshop. But if many workshops are being conducted by an engineer, this model will fail because it won't be able to tell you the names of all the workshops being conducted by the engineer, as this model do not support many-to-many relationship. It supports only one-to-many relationship. Also, in the context of technicians, this model, that is hierarchical model, won't be able to tell you how many workshops are being attended by a particular technician. Again, in this case, the number of workshops is more than one. So if there are many workshops, means there should be many-to-many relationship. But this model only supports one-to-many relationship, where there can be at most one workshop. So this model won't be able to tell you the list of workshops those are being attended by the technician. As a result, one-to-many relationship supports only one workshop, but there can be many engineers and many technicians. So questions involving many workshops doesn't fall into the picture. So these are the limitations of the hierarchical model, in which records are organized as a collection of trees. Now the limitations in the hierarchical model has been overcome by the introduction of a new model known as the network model. In a network model, the data is also represented in the form of records. But now these records are organized as a collection of link-like graphs instead of trees. And with the help of graphs, we can implement many-to-many relationships. This is indicated by arrows moving out from workshop to engineer, as well as arrows moving out from engineer to workshop. Same happens between workshop and technician. So as there is many-to-many relationship between workshop and engineer, as well as between workshop and technician, now we can find how many workshops are being conducted by an engineer. We can also find the names of those workshops being conducted by an engineer. In the context of technicians, we can also find out how many workshops are being attended by the technicians. We can even find out the names of those workshops those are being attended by the technicians. So clearly, the network model has an edge over the hierarchical model. The next record-based model is the relational model. The relational model uses the concept of a table, which is a rectangular-like structure with rows and columns. This form of a table-like structure represents the data and relationship among the data. The table has a number of columns with unique names. As shown in the slide, the name of the first column is roll no. The name of the second column is name, the third one is class, and the fourth one is class teacher. So all these are also referred to as attributes or field names in the table called classroom. The object-based database models is based on the concept of objects. In this model, the data is represented in the form of objects rather than records. The widely used models of this category are ER model and the object-oriented data model. You will properly understand the concept of object-based database model when I will give you a lecture on the ER model. The next type of data model is the physical data model. The physical data model is the lowest level of data model for database related implementations. In this model, concepts related to record formats, record ordering, and access paths are of prime importance. So these were all the three different types of data models that I have already explained. The first one is a record-based model which consists of three parts, that is the hierarchical model, network model, and the relational model. The second one was the object-based database model, and the third one is the physical data model.